Good morning, third grade. Our targets for today are I can identify the parts and whole in a put-together problem, and I can solve put-together story problems with a missing whole using a bar diagram. For the last 3 days, you've been learning about Get More story problems. In a Get More story problem, there is an amount, the starting amount. A Get More action happens, the Get More amount, and the total amount increases or becomes greater, the result amount or whole. You know that in a Get More problem, the starting amount is a part. The Get More amount is also a part, and the result amount is the whole. You also know that we represent Get More problems using a bar diagram with the parts inside and the whole on top. When we solve a Get More equation, we either add or subtract, depending on what information is unknown in the story problem. When the whole is unknown in a Get More problem, we add, because part plus part equals whole. When a part is unknown in a Get More problem, we subtract, because whole minus part equals part. The key words in a Get More problem that help you know it's a Get More problem are the Get More actions. A Get More action is any action that causes the amount to increase. Some examples of Get More actions would be earn, buy, make, find, grow, win. There are many other Get More actions. These are just a few examples. A Get More action is any action that causes the total amount to increase, and all Get More problems have Get More actions. We've also been talking a lot about parts and wholes. You know that we often represent parts and wholes with a bar diagram, and that part plus part equals whole. So when a whole is unknown, we add. Let's take a look at a quick example. You can see in this bar diagram the parts are 2 and 8. The whole is 10. This makes sense because 2 plus 8 equals 10. Part plus part equals whole. Take a look quickly at this problem with me. One of my parts is 6 and one of my parts is 3. N is the unknown and it's the whole. Think in your brain, what is 6 plus 3? That will tell us what N equals. Yes, 6 plus 3 is 9, so N equals 9. Today, we're going to learn about a second story problem type called put together. You have learned about put together problems in first grade and second grade. In a put together problem, there are 2 amounts. No action happens. The 2 amounts are then put together to make a new amount, the total amount. In a put-together problem, the 2 amounts are both parts. You can see here there are 2 amounts. One of the amounts is 2 teddy bears, that's a part. The other amount is 3 teddy bears, that is also a part. The 2 amounts in your put-together problem are both parts. Now, in a put-together problem, there is no action. The 2 amounts are simply put together or combined to make a new amount, the total. You can see here the 2 teddy bears and 3 teddy bears were put together. So now we have a whole of 5 teddy bears, all the teddy bears put together. In a put together problem, there is no action. The 2 amounts are simply put together or combined. There are many words that mean put together, and they're words that we'll see in story problems. They give us a clue that tells us this is a put-together problem. Sometimes in a story problem, you might actually see the words put together, that 2 things or amounts are put together. But oftentimes we see other words that are clues that mean put together. Some other words that mean put together are share, combine, all together, in all, in total, group, or put together. These words all can be clues that tell us a problem is a put-together problem. If there's no action and instead the 2 amounts are shared or combined or put all together, it is a put-together problem. Put together problems have two amounts, and you know that the two amounts are the parts. The whole is the amount after the two are put together. It's the total amount combined. We represent put together problems with a bar diagram, just like we represent get more problems with a bar diagram. The parts go inside, and just like a get more problem, there can be more than two parts. The whole always goes on the top, and there's only one whole. Just like get more problems, you could possibly add or subtract to solve a put together problem. If the whole is missing in a put together problem, you'll add because part plus part equals whole. If a part is missing, you'll subtract because whole minus part equals part. Today, we are only going to solve put together problems that have a missing whole. So today, we will add to solve all of the problems that we do because part plus part equals whole. Some key words that tell us a problem is a put together problem are the words combine, put together, in all together, and total. Remember, put together problems do not have an action. If a problem has a get more action, it is not a put together problem. Let's go ahead and think for a moment about how get more and put together problems are similar and different. Well, one way I know that get more and put together problems are similar and different is that they both have parts and they both have a whole. Some ways that they are different would be that a get more problem has a get more action, but a put together problem has no action. There are just two amounts that are put together. The key words between a get more and put together problem are also different. The words that would tell me a problem is a get more problem would be the get more action. If there's a get more action like earned or bought or found, then it's a get more problem. Put together problems, however, do not have a get more action. The key words that might help me know a problem's a put together problem would be words like shared or combine or put together. Another way that get more problems and put together problems are similar is that I can represent both using a bar diagram to organize my wholes and parts. Get more and put together problems have a lot of similarities, but they also have a lot of differences. The differences, like the fact that put together problems do not have a get more action, help me tell them apart. Again, we can see here that that get more and put together problems both have parts and wholes, and that we represent them with both with a bar diagram. We can also see that you might add or subtract to solve both problems. If a whole is missing in a get more or put together problem, we add because part plus part equals whole. If a part is missing in a get more or put together problem, we subtract because whole minus part equals part. The key words, again, are different. Get more problems have get more actions, but a put together problem have words that tell us we're putting things together, like combine or put together or all together. Today we're going to solve put together problems that have an unknown whole. So in our problems today, there will be two amounts. They will both be parts, and we will know both of the amounts or parts. You can see in this example, I know that one of the amounts is 2 teddy bears and one of the amounts is 3 teddy bears. No action will happen because there's no action in a put together problem. And the result amount will be unknown. It will be what we're trying to find. Let's go ahead and represent this put together problem in a bar diagram. We'll go ahead and start with our parts. One of our parts is 2 teddy bears. Our other part is 3 teddy bears. Our whole, which we don't know, is total teddy bears. Since I don't know it, I'll use N to represent the whole. N teddy bears in all. When I want to solve this put together problem with a missing whole, I add, because part plus part equals whole. To solve this problem, I'll add 2 plus 3 to find my total or whole N. Think in your brain, what is 2 plus 3? You're right, 2 plus 3 is 5, so N equals 5. we're going to use that same problem-solving process that we used to solve get more problems to solve put-together problems. This problem-solving process will help us solve any story problem type that we come to. We will use this same process all year. We'll start by reading and understanding the problem. You know that third grade mathematicians often read a story problem 2 or 3 or even 4 times to make sure that they fully understand it. While we're reading, we think, what do I know? What is the information they give me? And what am I trying to find out? What is the question asking? Step 2 of our problem-solving process is to determine the problem type. Today you know it's put together, and to organize the information. We organize put-together problems using a bar diagram. Step 3 is to solve the problem. We choose the operation that will help us. Do we add or subtract? And then we solve. Finally, step 4 is to look back and check. We look at both our work and our answers, and we think to ourselves, is our answer reasonable? Here's the put-together problem we're going to solve today. Wendy has a coin collection. She has 32 silver coins and 24 gold coins. How many coins does Wendy have altogether? We're going to go ahead and start with step 1, reading and understanding the problem. We'll read the problem again, and as we read, we'll think, what information do I know? What information do they give us in the story problem? We'll also think, what am I trying to find out? What question are they asking me to solve? Let's go ahead and read the story problem again, focusing on the information that they give us. Let's go ahead and read the story problem again, focusing on the information that they give us. Wendy has a coin collection. She has 32 silver coins and 24 gold coins. How many coins does Wendy have altogether? One of the pieces of information that I'm noticing they tell us is that Wendy has 32 silver coins. Let's read the problem again, and I want you to see if you can find the second piece of information that they give us. Wendy has a coin collection. She has 32 silver coins and 24 gold coins. How many coins does Wendy have altogether? Can you find the other piece of information that they give us? I'm sure you found it. You're right, 24 gold coins is the other piece of information. Now, what is the question that this story problem's asking? Let's read it again and think, what question are we trying to solve? Wendy has a coin collection. She has 32 silver coins and 24 gold coins. How many coins does Wendy have altogether? What is the question the story problem's asking? You're right. This story problem is asking how many coins does Wendy have altogether? Now that we've found the two pieces of information, Wendy has 32 silver coins and 24 gold coins, and the question, how many coins does she have altogether, we're going to go ahead and think, which of these pieces of information are the parts or the amounts, and which one is the whole or total? What are the key words that are helping us figure out which pieces of information are the amounts or parts, and which ones are the total? Well, I noticed that the first piece of information has the keywords silver coins. Silver coins helps me determine that this is a part because I know that we're trying to figure out how many coins there are all together, so silver coins are just part of the coin collection. She has other coins too. Silver coins are just some of them. Look at the other piece of information, 24 gold coins. What words in that problem help us figure out if it's a part or a whole? Well, of course, gold coins helps us know that this is also a part. Gold coins are just one kind of coins. We know that Wendy has an entire coin collection. So silver coins are some of the coins, a part, and gold coins are also some of the coins, a part. Go ahead and look at that question. Even though we know it must be the whole, because we've already found two parts, what words help you know that the question is asking about the whole? The question says, how many coins does Wendy have altogether? What words help you know that this is the whole? Oh yes, coins all together. It's asking me to find the coins all together, or the total coins, the coins after I put the silver coins and gold coins together. all together means I'm putting them together. So that helps me know that the question is asking me to find the whole. Now that we've really thought carefully about our problem, we're ready to plan how we're going to solve it. Normally, we would need to determine the problem type. We already know today that this is a put-together problem. And because there were gold coins and silver coins, and we're putting the coins together, it's easy to see that this is a put-together problem. Now we're ready to organize our information using a bar diagram. We're going to start by labeling both parts and the whole with words. We know that 32 silver coins is one of the parts. What words should I use to label this part? I'm going to use the word silver coins because that is what this part is. Think about the other part, 24 gold coins. What would we label that? You're right. We would label that gold coins because the fact that these coins are gold is what makes them different from the silver coins. Silver coins are one of the parts and gold coins are the other part. These are the two amounts. Now, think about that question. How many coins does Wendy have altogether? This is our whole. What words could we use for the whole? Oh yes, we'll label our whole coins all together because those were words that were in the story problem and they mean the same as total coins. Now that we've gone ahead and labeled our two parts, silver coins and gold coins, as well as our whole, coins all together, we can go ahead and think about what numbers go in each of these parts and the whole. Look back at the story problem. How many silver coins does Wendy have? What number goes in the part silver coins? You're right. Wendy had 32 silver coins, so I'll put the number 32 in the part labeled silver coins. Our other part is gold coins. Look back at the story problem. How many gold coins did Wendy have? What number goes with this part labeled gold coins? You're right. Wendy had 24 gold coins, so I will label the part called gold coins 24. Oops. You're right. Wendy had 24 gold coins, so I will put the number 24 in the part labeled gold coins. Finally, think about our whole, coins all together. Look back at the story problem. How many coins did Wendy have altogether? You're right. We don't know how many coins Wendy had altogether. The story problem doesn't tell us. In fact, that's what the question's asking about. So this is our unknown piece of information. What should we label this piece of information if it's our unknown? Oh yes, we always use N to represent the unknown information. So we'll put N coins all together. Excellent. Now we're ready for step 3, solve. We're going to choose an operation and solve this problem. Look back here. We can see that we know one of the parts, 32 silver coins. We know the other part, 24 gold coins, but we do not know the whole. When we do not know a whole, what do we do? Do we add or subtract? You're right. We add when the whole is unknown because part plus part equals whole. So let's go ahead and think about how we'll write our part plus part equals whole equation. Think about the first part. What is the first part in this problem? You're right. 32 coins is the first part. So I'm going to write 32 silver coins. I'm going to write 32 silver coins and then my plus sign. I'm going to add this part, 32 silver coins, to the other part. Look at the bar. Let's go ahead and think about what our equation for this exact problem will look like. We know it will be an addition equation because part plus part equals whole. What is one of the parts we're going to add? One of the parts we're going to add is 32. It's 32 silver coins. So I'm going to make sure and label it silver coins so I know what that 32 means. Think, What is the other part? We know that we're writing a part plus part equals whole equation. So what is the other part in the story problem? What will we add to 32? You're right. We'll add 24. You're right. We'll add 24 gold coins to the 32 silver coins because the silver coins and the gold coins are our parts. Now, what will that equal? What is the whole? Oh, that's right. N coins altogether is what we're trying to find. So 32 silver coins plus 24 gold coins will equal N coins altogether. Now, you know as a mathematician, when we're ready to solve an addition problem, we never write them horizontally or side to side like this. We always write them vertically, with one number above the other, carefully lining up our place values. Here you can see I've written 32 plus 28 vertically, carefully lining up my ones place and tens place. Now I want you to think in your brain, when we add two numbers, in what place value do we start? Yes, we always start in the ones place. So let's take a look at the ones place of this equation. 2 plus 8. Ooh, I noticed that 2 plus 8 is an easy 10. It makes a 10. So I'm going to regroup that 10 to the tens place. That will leave me with 0 ones, and one more 10. Like this. I know that 1 plus 3 plus 2 is 60, so I have 0 ones and 6 tens. My answer to 32 plus 28 is 60. I now know that N coins altogether equals 60, so I'm going to write that. N equals 60. I'll also add this to my bar diagram, showing that N equals 60 coins altogether. The last thing we need to do as we're solving this problem is to write an answer in words. When we solve a story problem, we always write our answer in a complete sentence, and we make sure to restate the question in our answer. Sometimes, after I've worked so hard to solve a story problem, I kind of forget exactly what the question said. So I'm going to look back at the question and reread it one time so I can make sure I answer it correctly. The question in the story problem said, how many gold coins does Wendy have altogether? Oh yeah, that was the question. How many coins did she have altogether? Think. How could I restate this question so that I am answering it in a complete sentence? You're right. We could restate this question and answer it by saying, Wendy has 60 coins altogether. Awesome, third grade. The last step in our problem-solving process is to look back and check. We're going to look at our work and the answer, and we're going to make sure our answer is reasonable. The first thing I like to do when I'm checking my work is I like to make sure that the numbers I wrote in my You know, as a third grade mathematician,
go up behind you in a minute. Can I just go up behind you in a minute? See you.
You know, as a third grade mathematician, that whenever we go to solve an addition equation, we always write it vertically, with one number above the other number and each place value carefully lined up. You can see that I've written my equation 32 plus 24 vertically here, with the ones place and tens places carefully lined up. In which place value do we always start adding? You're right. We always start in the ones place, so that's where I'll begin. I know that 2 plus 4 equals 6, so the answer in my one place will be 6. I know that 3 plus 2 equals 5, so the answer in my tens place will be 5. When I add 32 plus 24, it equals 56. N equals 56, so I'll go ahead and write that and include it in my bar diagram. N equals 56 coins altogether. The final thing we need to do to finish answering this question is to answer the final thing we need to do to completely answer this question is write our answer in words. Sometimes when I'm solving a story problem, I kind of forget exactly what the question said. So I'm going to look back up at the story problem and reread the question to remind myself. How many coins does Wendy have altogether? That's the question in the story problem. How could we restate that question to answer this problem in a complete sentence? I agree. We could say, Wendy has 56 coins altogether. The last thing we need to do when solving a story problem is look back and check. We need to look at our work and answers and ask ourselves, is our answer reasonable? I always start by looking at my bar diagram and making sure that the numbers in my bar diagram match the story problem. 32 silver coins, yep, that matches the story problem. 24 gold coins, yep, that also matches the story problem. Then I take a look at the equation I wrote. My whole was missing, so I added part plus part equals whole. And I said 32 plus 20, oops. And I said 32 plus 24 equals 56. 32 is a part and 24 is a part. 56 is my whole. It makes sense that 56 is larger than both of the parts because 56 is the whole. Finally, I look at my question, my answer, and I ask myself, did I restate the question? Did I write a complete sentence? Wendy has 56 coins altogether. The question asked, how many coins does Wendy have altogether? So my answer, Wendy has 56 coins altogether, answers the question and restates it. Thank you for solving this put together problem with me today, third grade. We're going to solve some more put together problems tomorrow.